All right, so I've come up with a few questions I think would be good for you to help review for the parametrics test. The first part of this lesson today is a review for that test this tomorrow. The second part, the last 15 minutes-ish, is going to be talking about the lab. There is a lab that we need to complete, and we'll talk about that later. So to start with, this one. Find a parametric description for this. And I remember telling you before when I gave you an equation that said y equals blah, 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 and I said x equals, repeat after me, x equals t. But then this one doesn't really go like that. Okay, I'm going to pause for a second while you give this one a try. So, how did you do? Well, was anybody bothered by this question? Like, did something feel wrong, or are we good? Yes? Yes? Why? Okay, so let's talk it through. Would you agree the catch here was x equals this, so y equals t would be a good equation, right? And x equals 2t cubed minus 3. Are you with me so far that that would be a good parametric for this? All right, in the interval for t, tell me why that bothered you. Well, first of all, what did you think the answer was, given what the question was? So you were thinking, why were you thinking that way?
Because y equals t, and then you just take the y with the corner to be right.
Yeah, since y equals t, then it should be based on these y numbers. But why did it bother you? What seemed wrong about it?
Because normally when we get the coordinates, we just put y is equal to y equals 0 and y equals 1.
I'm going to say that a different way. I'm going to say you could put it in a TXY chart, and it should work. Now, some of you have this, and you're like, blah, 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 that's the answer, server. Well, kind of, but it's wrong. Why? Why is it wrong? Because the problem is wrong. But you should have been bothered like he was that there's something wrong with this. This isn't working. Okay, and the way you should have caught it is you should have made a TXY chart. How many groups actually made a TXY chart or attempted to? Okay, so my point is, you remember me saying check yourself before you wreck yourself on these things? You should check your answer. This answer does not work with these points. All right, so let me show you why. If I put in 5, like you're saying that 5 and 6 seems right to you, so I put in a 5 here. Then when I put a 5 in here and here, I'm supposed to get one of those points. Well, I get y equals 5. Seems like it's this one. But when you put a 5 in here, do you get that? Does not work. Not even close. That doesn't equal the other point that goes with it, which should be x equals negative 3. I get the x equal, or sorry, I get the y equal to 5, but I don't get the x. I don't get a negative 3 for this. That's not negative 3. So you should have caught that. So I kind of actually like this question, even though it's a flawed question, because the answer is there's no solution. And you should have known that because you should have checked the TXY. So you were absolutely right. And something bothered you about this because you were saying, I can't make the points work. Yeah. When you stick the numbers in, it's supposed to work. So let me just show you what the points should have been so that this could be so that you could use the same process but actually have it work at the end. So again, what's the moral of the story? Check yourself. Make sure the TXY chart matches up. All right, so here's a couple points that had they been given to you, nobody checked it, so it doesn't even matter what the points were. But if you had checked it, these points would have worked. And so now you were right that we want to generally say, since y is t, that the t is based on the y values, which is that and that. So now what is this going to be and what is this going to be? Between what and what? 0 and 1. But again, you guys just kind of blindly trusted that was right. Now check it with your chart. Make a TXY right now and make sure it works. I get you're probably like, well, you gave us a flawed question. But the point is you didn't check, and your equations weren't right. You should check it with the TXY. So now t is 0, because it says so. Stick that in and see if you get one of your points. If I stick in t equals 0, then if t equals 0, then y equals 0. And it looks like I'm zeroing in on this point. And then let's see if that other one works. It does. It's -3. Look at that. See what I'm saying? That's how you check to make sure it's right. And if it's not working, you know, ooh, I'm doing something wrong. I'm not going to say that the problem is going to be flawed. I'm saying if yours doesn't match up with those first 2 points, then you must have done something wrong in your equations. Okay, so I'm going to take this other one and just make sure the other one's 1. I stick a 1 in, and when I stick a 1 into this, I get y equals 1. It seems like it's going to be that one. And I get 1 here. 1 to the third is 1 times 2 is 2. 2 minus 3 is -1. Look at that. It works. Okay, cool. Yes? I said already that we're not going to give you an on-purpose flawed question. This was more about, moral of the story, nobody except maybe one group had checked to see, is my equation actually working? So check, okay? So on the test, we're not going to give you a flawed question. All right, so moving on to number 2. Find and simplify a function in rectangular form for the system of parametric equations, and here they are. X equals t plus 5, y equals 6t minus 3, and it does say its domain is all reals. We've never seen that before. So that means t could be anything, right? All right, now I'd like you to turn this into rectangular, and it still needs a domain, even though that seems like, well, the domain is nothing. No, actually, the domain is everything. See if your answer also has a domain of everything. All right, so convert this over. I'll pause for a second. We give that. You now have solved for t, I bet. I hope you did. And you got t equals x minus 5, right? And so you'd have x minus 5 equals, and then the other one, you're going to add 3 to both sides, and you divide by 6, and you get y plus 3 over 6, and then it didn't say what to solve for. I'm going to tell you on the test, solve for y. Okay, that's the one you usually solve for anyways, right? So I'm going to times both sides by 6. Notice I'm not just going to times the x by 6. I got to times both parts by 6. And then I'm going to subtract 3. So 6x minus 30, and then I'm going to subtract 3 from both sides, and then I got y alone. Okay, so what is -30 minus 3? -33. Raise your hand if you had that one right. Awesome. And then, what's the domain for it? And if you think about what this equation looks like, really is it all reals? Well, did anybody even make a sketch of it? That would have been smart. Because what if it was a parabola? Then would it be all reals? Well, domain would be. The range wouldn't have been. Anyway, here I'm sketching it. It goes through -33 and it has a slope of 6. Now that I'm looking at it, does it seem like it has a domain of all reals? Will it go forever left? Yeah. And forever right? Yeah. So yeah, it's all reals. Drawing the picture really helps you get the feeling, especially on this one we're going to do in a minute here. All right, this next one is graph this system. X equals 2 plus 2 cosine t, and y is 3 sine t. Notice t is between 0 and pi. All right, to graph that, I would recommend a TXY chart. Pause for a second, let me give that a try. Okay. T, X, Y. Now we have 0 goes in there. I'm going to call on some random people to find out what you put for the 0 one. It is row 6, person 3. It's going to be you in the black shirt. Okay, Y is? And how did you get that? Help me understand. Where do I put this 0? How did you get your answer? Where do I put the 0? 0 is the t, so, okay. So it's cosine of 0. How do you do cosine of 0 again? I know there's somebody sitting at home who's like, I don't know what the cosine of 0 is. Okay. So if I draw this, and here's 0 degrees, then I use this is what comma what? 1 comma 0. On the unit circle, that would be 1 comma 0. And then cosine is the what? X. So that makes this a 1. So then 2 times that, 2 times the 1 gives me 2 plus 2 is 4, and that's why you got a 4. All right, nice work. And then sine of that is the y, that's 0. That's 0. 3 times 0 is 0. That's why you got a 0. Okay, good job. I don't want to explain them all that slowly, but I just wanted to make sure you got an example of how to do one of those. All right, SD in the back corner, would you give me the next 2 points? You put in 0. I'm going to take a wild guess. You put in some other angle that you know well.
Yeah,
Pi over 2 is a good call. And what do you get when you put in pi over 2? Can anybody verify that they got that? A lot of people did. Good. And then we could even do more points. And generally, on the test, we're going to tell you how many points you have to do. Okay? You had, you could argue 3 or 4 spots here, so I'm at least going to do one more point. Always do the endpoints. This is pi. And if you put in pi, it's row 5, person 3, 2, 3, 4, 5. Person 1, 2, 3, I'm going to construe that as you.
okay.
What did you get for pi?
0 for X. 0 for
0, 0. Ooh, special. Raise your hand if you had 0, 0 for that spot. Okay, awesome. Then, when you actually graph this thing, I hope you got a graph that includes 0, 0, and it includes 4, 0, and it includes 2, 3, and then if we put in a few more points, did anybody remember to put a little arrow on it saying which direction it was going? So easy to forget that. All right. If I remember right, isn't it going this way? Okay. So it's going that way. But you don't put arrows on the ends because that implies it keeps going, right? And this stops. And last, I had some people ask, should I have put t equals whatever on the graph? Like, for instance, right here, where we got 1 commas. Wait a minute. 0, 0. Let's do 0, 0. That this was t equals pi. Yes, that's great. When you have to have it is when it's time. Because when it's an angle, it kind of doesn't make as much sense. So I wouldn't have made you have it if it's time, or if it's an angle. But if it's time, yes. You need it there or you're going to lose 5%. Okay. What's next? Well, you remember yesterday. Yesterday, you used a graphing calculator. And I want to see if you still remember how to use the graphing calculator. So grab your graphing calculator and just graph that last one, the one you did by hand. Graph it and make sure it actually looks like this. And if you want to see it go slowly from one side to the other, there is a way to do that, to see that it's graphing it in that order. All right, I'm going to pause for a second. We'll try that on a graphing calculator. Okay, so I could put it in my calculator like this and still not have the right answer. Why? What could I be doing wrong and not even know it? Yes, sir, in the back. Yes, and where's that found? Into window, and I want between 0 and pi. So yes, that is critical. I hope you noticed that. Now, if you don't like how these other numbers look, you're going to have to play with your x-min, your x-max, that's how wide it is, and your y-min and your y-max, that's like how tall it is, until it looks okay to you. But remember, I'm not going to be looking at your calculator. You're going to be like sketching it on your paper. All right, so if this was slightly skewed a little bit because you're, like it's actually supposed to be more like a circle and yours is a little more like an egg, I'm not going to mark it wrong. Okay, but don't let it be hugely skewed. I could make this look like it was, like that, and that would be bad if you are way, way off. Okay, so try to make sure your window is reasonable. All right, last thought. Your calculator doesn't have this on it, but you have to. Don't forget the directional thing. And if it's a time equals, the calculator is not able to write t equals 0 and t equals 1 and etc. And this one's at angles anyways, but don't forget to put those on there. Okay, good. There's a quick reminder of how the calculator works. Next thing, do you remember yesterday, I told you how to make a circle with the calculator. Don't use the calculator. I want to know what an equation would be that would give you a parametric set of equations that would give you a circle with a radius of 7. See if you have a short-term memory. I'm going to pause for a moment. See if you can pull off the equation parametrically for a circle. I'm going to give you this hint. It involved trig. And it has a radius of 7. Now, by the way, somebody smart's going to ask, well, what's the domain? I'm just going to say I want the whole circle. I don't want just part of the circle. I want it so that when you would graph it, it would give me the whole circle. Okay, I'm going to pause for a second. Okay. By now, you should have remembered that the x was the cosine part, and you need t's to make it parametric. And this is the sine part. I do that, I get it wrong because I asked for a radius of 7. And some people thought I was like supposed to put a square root of 7 here or something like that, or 49 there. Nope, you just put a 7 there. Raise your hand if you had that one right. Awesome. Now, if you want the whole circle, you'd need a domain of what would you want for angles? 0 to 2 pi. Now, if you want to confuse the issue, you could argue something about maybe no solutions, but all real numbers. But on your calculator, you have to tell it what to start with and where to end. So we're going to just say it's 0 to 2 pi. All right, next, I think you probably knew this was coming. Change that over into rectangular. See what the rectangular equation for that would be. And you can't just slap it out of memory like, oh, I know the equation for a circle. You have to be able to prove it. Okay, so you're going to have to be able to take it from this, do something to your parametrics, put it all together, turns into rectangular. And don't forget the domain also. I'm going to pause while you give that a try. Okay, so you square both sides. I hope you remembered that. And then you got, well, I'm going to add them together. X squared plus y squared. And in case you're ever challenged on why can you even add these together? Well, you can add anything you want to an equation. There's an equation, right? I can add anything I want to it as long as I keep the same thing on this side and this side. Well, they're defined as equal. If this equals that, then you're adding the same thing on both sides. Okay, so that's why you can do that. Now, I've got 7 squared is 49 cosine squared t and 49 sine squared t. And then I have to factor out the 49s. 49, if you can factor it, you should. Cosine squared t plus sine squared t. And then, that's a lot of work. Do we have to show your work? Yes, you have to show your work. You can't just slap out, oh, I know that's that. I know it's a circle with a radius of 7. I know, but you got to show your work. Okay, then, this is 1, by the way, in case you didn't catch that. That turns into a 1. And then I've got this equation. And then I can say, what? Well, is this domain actually all reals? Nope. If you actually draw the picture, I really strongly recommend you sketch these pictures because it helps a lot. If this had been this part of the circle, do you get your domain would have been like from here to here, from here to here? If it had been just this part of the circle, then your domain would have been from here to here. Well, we had the whole circle, so our domain is from here to here, which is from -7 to 7. How many of you had that right? Okay, if you didn't have that right, you're going to get a chance to redeem yourself, because I'm going to change the original question now, just a little tiny bit. Don't have to redo everything, just the domain. What if I had said that it was from pi over 2 to pi? Then what would the domain be? If I only wanted from pi over 2 to pi, then what's the domain of your circle? I'm going to pause for a second while you give it a try. Okay, if you sketched it, you should know that from pi over 2 to pi is right there. So then, what's the domain of that? From -7 to 0. Raise your hand if you had that one right. Awesome. Then, wow, we've pretty much covered everything. Now, your homework for tonight, we'll get to in a little bit, is you're going to do one of those, you pick the review problems deals. Okay, this time I decided that I was going to give you 2 points for showing me a picture of some notes that you have taken. Just take a picture of some notes, drop it in. That's worth 2 points. Have you ever taken notes? I hope so. Okay. You'll be one thing at a time. I'm talking about is the homework for tomorrow is to do 7 points total. 2 points is to show me a picture of some notes you've taken. 5 points is for doing 5 practice problems. Okay, yes, I opted 1. Last time it was 4, now it's 5. I really encourage you to practice for this one. This should be an A. You should be able to pull off an A, which could make up for some of you getting a C in the last test, you know, and then at least it's a B between the two of them. And most of you want an A when it's all over with, right? So I'm hoping you pull off an A on this one, and then some of you can be like, okay, I guess I don't have to retake that other test. I got an A on this one. But time will tell. Will you study enough? That's the question. All right, 12 minutes left. That's my sign today that I need to show you about the lab. So right now, take your iPad and find the file for the lab. I'm going to pause while you do that. It is called the Complex Numbers Lab. And yes, you should slide apart from your partner. They are not helping you with the lab. Okay, you're going to find this file. It's called the Complex Numbers Lab in a folder called Lab. You really want to get that open right now so that you can take your notes right onto your lab document. This is where you're going to do the lab. All right. Okay, now, this is kind of dense. I'm going to explain it to you verbally and give you all the hints that I would normally give you over the much longer course of time. But I find myself really rushed, and I don't want to miss this lab. It's a cool lab, but I need to give you all the hints that I would give you normally spread out over the course of 2 or 3 different times of working on it with a partner. I'm just going to hit you with it all at once. And then you can work on it tomorrow, because a lot of you guys are going to finish the test. You're going to say, that was easy. And you're going to be done, and you're seriously going to have a half an hour to work on the test. All depends on how fast you work. But tomorrow after the test, you want to have time to work on your lab, because the lab is due Monday, this Monday, as in over the weekend, you do this lab. But I'm going to show you so much, and I'm recording this, as you might remember. You can look back at this if you want, that you really don't have too much left. It's going to be pretty quick. And yes, this is a normal lab where I want a purpose, and I'll tell you the purpose right now. The purpose is to find the distance, and you don't have to write this down, but to find the distance between consecutive roots of 1. All right, so to help us do this and help us see it, you're going to want to get Wolfram Alpha going. And it's a website, WOLFRAM space ALPHA. Wolfram Alpha is awesome. We're going to pull it up on your iPad right now. Okay, side note, fun thing you can do is type in your name, and it'll tell you how many people have that name. Isn't that kind of cool? 81 people per year are named Dave. What do you think would be a lot more than that? David, D-A-V-I-D. Show you. So anyway, if you want to know more about your name and when it peaked in popularity and all that stuff, 10,000 Davids are named every year. And it peaked in popularity back in 1955-ish? Anyway, and there's been a slump in Dave production lately. All right. I know that might be somewhat interesting, and you should definitely dig into your name later. I think you'll think that's cool. But would you please, right now, put in 1, like the number 1, to the power of, parentheses, 1/3. Do you get that that is finding the 3rd root? Okay, if I hit enter, it's saying, okay, fine, that means this. See? Cube root of 1. What we really care about, though, is it has all these cool things about 1, but go down here to the plot of it in the complex plane. Do you get that those 3 dots there are about as far apart from each other as they could be? Think of it as like a circular table, and you have 3 kids, like let's say they're siblings, and they're all mad at each other, and they're trying to sit as far apart from each other as possible. Okay? The question is, how far apart are the consecutive roots. And by the way, I don't mean like on a curve. I don't want the arc length. I'm saying, how far is this? Well, let's dissect it pretty quickly. It's the number 1. What's its radius then? Well, to graph it, I go over 1 and up 0, and it's right there. And so what's the radius? 1. Do you get all of these are 1 then? 1, 1, 1. Those are all 1s. Okay? And I know you're thinking 1, 1, 2, but that would be if it was a 90-degree angle. It's not a 90-degree angle, and therefore I have to use something else. Has anybody yet figured out this is 120 degrees? How'd you do it? 360 divided by 3, exactly. What if there'd been 4 roots? 360 divided by 4. What if there'd have been 5? 360 divided by 5. But here's the kicker. What if there's n roots? What would the angle be? Ooh, and now change it to radians because you're smarter than degrees now. 2 pi over n. All right. So what we just figured out is that angle right there would always be, what again? What did you just say? 2 pi. You were saying 360 divided by how many sides, but I changed the 360 to 2 pi. Do you get we can do that? And then I changed the number of sides to the number of roots, and the number of roots, I said, we don't know what the number of roots always is going to be, so we're going to call it n. So this angle, and this is what you need to write down. I'm giving you way too much help, way too fast, but that, as you came up with a little guiding from me, that angle is 2 pi over n. Now, one more thing, just to clarify, this is always going to be the roots of 1, which means these sides are always 1. You have to get, those aren't going to change. Those are always 1s. Even if I make it the 5/5 roots, it's the 5/5 roots of 1. Okay. Then, another little piece. Do you get if I did this again, except with 5 roots, there'd be 5 dots equally spread out around the circle? You getting that? Okay. So then, if we had the dots and the dots weren't exactly on this line, do you get we could rotate it until the dots were on that line? Okay, next, do you get that this dot is a really simple point? It's what, comma, what? Don't put away your stuff yet. There shouldn't be any noise from people putting stuff away. All right, that is at 1, 0. Good. This side is how long? This side is always how long? But this spot isn't always something. It depends on how many roots there are. And this angle depends on how many roots there are. What did we say that was again? 2 pi over n. And so this distance here, I'm going to make it this green line. This green line depends on how many roots there are. The distance between the consecutive roots depends on how many roots there are. Oh, I see it. Yay, I get an Easter egg. One step closer to a titanium shovel. All right. I'm going to have to buy it because I'm running out of ideas of stuff to buy, so I'm just have to get that shovel. Okay. So, how do you finish this? What's the point, Mr. Server? What are we supposed to do in this lab? What you're supposed to do in this lab is tell me, if I just tell you that you have n roots, I should be able to tell you any number. You should have an equation that will tell you how far apart these roots will be. Well, first of all, let's say that we knew again that this was 120 degrees. How would you figure out that side? And no, you can't do like it's a right triangle, that it's the 1, 1, root 2 triangle. It's not. There's something about sines and cosines and stuff. Okay, so give me more. Law of, I heard law of. Law of, except law of sines only works if you have a side across from an angle that you know. If you have a side across from an angle that you know, but we don't. No, but we don't know. Okay, I get you. We could make it this. We could figure out what that angle is. That's true. But just wait. You need to use the law of cosines, if nothing else, because that's what the lab says you have to use. Is the law of cosines. Okay. Besides, then your little angle wouldn't be so nice anymore. Our angle is always 2 pi over n. And then yours would have to be 180 minus that, and we get really much more complicated. Okay, so back to law of cosines. If I were you, I'd write this down. A squared, who can finish the law of cosines for me? Plus b squared minus some factor, do you remember this? 2ab cosine of c, that's a big C, it's the only angle up here, equals not c, c squared. There's your law of cosines. And this c here, that has to be our distance. I know it's going to bother some people that c is distance, because you want to make it d is distance, right? But we're going to say that c is our distance. So we need to know this distance here, and if it was 120, I'd put the 120 here. Is it always going to be 120? No. But what could I put in that would always be the angle? 2 pi over n. All right, and I got you off and running. I want a equation so that when it's done, your equation has just an n in it, and it tells me the distance between the roots. Okay. Okay, I get what you're saying. We need one more piece of information. And let me show you that one more piece of information. You need to know where that spot is. To be able to do this, you're going to need to know what that spot is. So I'm going to tell you, I'm going to actually ask you, if the angle, we're not calling it 120 again, because it's got to be any angle that happens to work, which is going to be 2 pi over n. Then this is either sine or cosine. Which one is the x? Cosine. And if I say cosine, it's meaningless without an angle, so it's cosine of what? Cosine of the angle. What's the angle again? 2 pi over n. And then if that's cosine, what's that? Sine. All right, now I could find the distance between this and this with the distance formula if I wanted to. Because what's that spot again? It's always going to be what comma what. Do you get, now I can find the distance between those 2 points? You have to finish this. I'm not finishing it, and I've given you too much already, but we have very little time. And I didn't want to just skip this lab. So, all right. Of course you think we should have skipped the lab. But your job, write me an equation for the distance between those roots, except it only has an n in it. And you've got everything that you need. And it comes down to using law of cosines. Do you have to have a purpose? Yes. The purpose is to find the distance between any 2 roots of 1 if you're only given how many roots you have. Okay. Remember, your biggest job for tonight is not this lab. If you want to get started on it because you feel like, I think I got it right now, I'm just going to do it, fine. But your more important job right now, study for the test tomorrow. That's all I got for you for today. Have a great day.